Yes, welcome to my channel. Good day, everyone. Today we are looking at circuits, current electricity, right? Ohm's law, applications of Ohm's law, and the situations where we have to deal with a real battery. A real battery has internal resistance, right? So, this question is like, they say when the switch is closed, the current passing through that 8 ohm resistor is 0.5 amps. And we must try and find the ammeter reading. Right. So there's two things that we need to do first. The first thing, obviously, when you are given something like this, is to study the drawing. Right. So you can see the battery terminals there. The positive side is the long, this long. Yeah, if you look at the one cell, the shorter one will be negative. So negative will be this side, positive is this side. So the current, by convention, flows from positive to negative. So the conventional direction of current flow will be this way. Comes there, splits. Some of it will go through that resistor R. Some of it will go this way, and then it splits again into these two resistors which are in parallel. Right? We joins, passes through A1, gets to the 20 ohm resistor, and then gets there, right? And then it combines with current coming from this resistor. So it's going like that, and you continue the arrows, then it's going to go down there, they recombine these two currents to form the main current, which just passes through the battery again. Remember, when there's internal resistance, it's not easy for the current to push through there. So some of the energy that the charges have will be lost inside the battery itself due to resistance. Right. So when the switch case is closed, the voltmeter reading across the voltmeter reads the V, what we call V terminal or V load. It is the energy per coulomb that you need to push the current to the external circuit. Right? And also when the switch is open, it will give you the EMF of the battery, which is unknown. Okay. We sort of will try and give the questions out as we go along. Right. So it was from the NSC 2015 paper. So the first question that they asked is, they said the Ohm's law, state Ohm's law. Right. So this one you just have to know it. But for me, the easiest thing to remember Ohm's law is to write the equation for Ohm's law, which is V is equals to, yes, I times R. That helps with the state Ohm's law. So if you are writing an examination where the formulas are provided, it is an open book exam. You just say, you can see that the resistance is a constant. So all you can see is that when current increases, the voltage also increases. So you can say that Ohm's law states that the current, although you have to start from the right, but once you have got this, you can state it. The current flowing through a conductor is directly proportional to the voltage across its ends, right? Provided the temperature remains constant. Right. Okay, that's good. Provided the temperature remains constant, because you know that some materials, when the temperature is increased, the resistance either increases or decreases depending on the type of conduct. You need to study that as well. Okay, so that was the first question. State Ohm's law, 2 marks. You get that one. Then the next question they asked is, calculate the ammeter reading A1. Good. You are given that 0.5 amps is passing through there. So these two resistors are in parallel, and these two are in series with that one. all that setup is also in parallel with that. That's the first thing to recognize. Okay. So if this one is double the resistance compared to that one. So if this one is taking 0.5 amps, because when the current gets there, it has to choose the easy. That when it is easier, there will be more current. So obviously, more current is already going to the 8 ohm resistor, and less will go. So the easiest way is to apply the knowledge of okay. Let me ask you, what is the best way to get the ratios. Yes, ratios, you can use ratios, but bear in mind you can't use ratios if there are 3 resistors. You can only apply that method if you have 2. When you are 3, it becomes a challenge. So I will leave the ratios I'll still use it as an example, in which case let me do the voltage method. Okay, the voltage between the resistors that are in parallel, the voltage between resistors that are in parallel is the same. So if you put a voltage across it will be the same voltage as the voltage across one of them. So if you also put a voltage across this one, it's exactly the same voltage. So if you can use Ohm's law to get the voltage across the 8 ohm resistor, we already know the voltage across the 16 ohm resistor, or across both of them. Right. Let's do that method first, then we can do the ratios. So the voltage across the 8 ohm resistors, when we just put that one there, it will be V equals to current 0.5 times 8. So it's half of 8, that gives you 4. So the voltage across the 16 ohm resistor is also 4. So if you were to put let me just put it there, if you were to put a voltmeter there, it will also read 4 volts. If you were to put a voltmeter across it, also read 4 volts. Right. So how much current is passing through there? Ohm's law again is equal to IR. So 4 volts is equal to whatever current times R is 16. Very good, 50 times 16. Okay, so your current is, what is it? A quarter. So that gives you the current would be equals 4 over 16, which is 1 quarter, which is 0.25 amps. So you are going to get 0.25 amps going that amps. Okay. So first question is answered. Ammeter reading will be combined here to be 0.5 plus 0.25, which gives us 0.75. So A1, right, is going to be this plus 0.5 is 0.5 plus 0.25, which is 0.75 amps. That will be your ammeter reading there. Good. Then the next question that they asked was, I hope I still remember the questions. They said, yeah, you are given the power. Yes, let me pull the question quickly. Yeah. Calculate the reading on A1, that was done. Then they said the device R delivers a power of 12 watts. Calculate the reading on the ammeter A2. Right, we are given the power, right? What can we get here? Power is the equations of power. Can I remove this? All of this? Power is, you can use the power because I said power is equal to VI, power is equal to V squared over R. You remember all those equations. So this is the 12 watts. So it's 12 power there. Yeah. Power is 12 watts, right? Calculate the reading on the ammeter. So if we have voltage, ammeter reading, yes, some people get confused. Ammeter is a low resistance device connected in series and it reads the current. Right. Voltmeter is a high resistance device. Its purpose is just to read the work done, the coulomb of charge that you okay. So this one then we need when they say calculate A2 ammeter, it means they want us to find the current, the voltage. We can get the voltage because we know the voltage across. Remember, this whole setup at the top there is in parallel with this one, and then the voltage across this is the same as the voltage across. Right? The voltage across all these resistors at the top is the same as the voltage across R by the same principle that I applied there. Then what I'm going to get there is going to be current 0.75 times 20. So 0. V is equal to I R. So you are going to get 0.75 times 20. It looks like 10. Yeah, it looks like 7.5 times 250 volts. Right? So V is equal to IR. Across the 20 ohm resistor there, will give 15 volts there. So if you put your resistor there, it will read 15 volts. So altogether, 4 and 15 is 19 volts. So the voltage across the R, if you would put a resistor there, it will be 19 volts. So now we know V, or we need to find the current through resistor R. So it's now very easy. So that would be the power is 12. I'm just substituting into this one. Maybe it's clear if I do like this. Power is 12, the voltage is 19, the current is unknown. Okay, so I is going to be 12 over 19 amps. You could use a calculator there to calculate the current. Right, what else did they ask me? Calculate the reading on the voltmeter when the switch S is open. Okay, when the switch S is open, we talked about it already, it will read the EMF. So you just need to just put the formula there. EMF, let me write it at the top. Yeah, to get the EMF now, which is the reading when the is no current. So, but you can use the information we have. The formula for EMF or E is V external plus R if it is delivering current. But you can actually calculate what when it's closed, it's delivering current, so we can use this formula to get this. This is a constant. Little r is also a constant. It's 1 ohm is given. I think that's why they gave us. And then the total current now, it was 12 over 19 there. It was the 0.75 amps. If you add these two, that will give you the main current. Because it's going to be main current here times big R. Total external resistance plus main current times little r, which is given. So you can calculate the EMF. I won't go into that because of time. I want the videos to be shorter. So then you can calculate the EMF. You can get the main current by adding. I think that was the question. What else is important here is that there are questions that are very common in the exams. The total resistance, which you call big R, is the people, you need to focus on it a lot. What happens if the resistance increases? It means the main current will decrease, right? And vice versa, right? And we need to be familiar with situations where if the resistors are in series, if you remove one, the total resistance big R decreases. But if resistors are in parallel, if you remove one, if you have two resistors, for example, which are in parallel, and you remove one, the total resistance actually increases, because resistors in parallel, the total resistance is decreasing. Remember the way you find the R parallel, the combined resistance for parallel resistors. One over R parallel, you can sometimes you have to try it out, because, for example, if you use a variable resistor and you decrease in your resistors are in parallel, and you decrease one of the resistors, let's say one of the resistors is a variable resistor, you can decrease it. It does not mean that by decreasing, it does not mean that you are going to increase the resistance. You actually decrease the combined resistance. So you need to be very tricky. So you will need to sometimes play around with your mathematics on the side. And, right. I hope you have enjoyed this, and hope to see you again with the next video. We want to do our best. Please don't forget to get hold of me on my email address, which is my first name, surname, Ramas Mazoze @gmail.com. If you need online lessons, please don't forget to get hold of me. We want just to be the best. Thank you.